Okay, let's start with the course then. So in the last class, what we have discussed about the routing protocols. Uh, what are the designing goals? What are the challenges? And what are the classifications? Okay. So basically, the routing protocols are classified into four types based on four individual categories. The first category is routing information update mechanism. The next one is uses of temporal information. The third one is uses of topology information, and the fourth one is uses of specific resource. So basically, based on these four criteria, the routing protocols are divided. Okay. Now, what you do, you draw a tree-like structure. Okay. In the middle of the page, in suppose you um, take a page on a landscape mode, then in the middle of the page you write the routing protocol. Let's design a tree like structure, or normally you can write that the routing protocol four types, and these four types again individually subdivided into multiple types. For example, the first category, that is the routing information update mechanism. This routing information update mechanism, this category of protocol again subdivided into three types. Number one, proactive or table driven writing protocol. Proactive, or you can also write as a slash, or within bracket also you can write table driven routing protocol. Number two, reactive, similarly within bracket or slash on demand routing protocol. And the third one is hybrid protocols. Means the first category is classified into three types: proactive, reactive, and hybrid, in short, or table driven, on demand, and hybrid. Similarly, the next category, which is based on uses of temporal information, this category is again classified into or subdivided into two more types, two more subcategory. One is called based on past temporal information. The second one is called based on future temporal information. Okay. Next, come to the third category, that is based on routing topology. Okay. There are different types of topology. Okay. So one category is based on flat routing topology. Flat routing topology or flat topology routing protocol, or the next one is hierarchical topology routing protocol. Okay. And the last one is based on utilization of specific resources. For this, again, two subcategories are available. One is called power aware routing, and the second one is called geographical information assisted routing. Okay. And then now let's start with the first type, that is update based on the update information or update mechanism. Okay, routing information update mechanism. Anyone have any idea? Or what is proactive routing protocol? Under the routing information update mechanism, the three category is, one is called suppose proactive or table driven. The next one is called suppose reactive or on demand, and third one is called suppose hybrid. So hybrid means basically the combination of both proactive and on reactive. And what is proactive actually? Proactive. I think this name itself um, explain its activities. How a proactive entity works. That means before executing the operation, it will prepare all its requisite information. Okay? That is called proactive. So in proactive, what happened? It maintain a fresh list of destinations and their routes by periodically distributing routing tables. So that means in this category, they maintain a table. They maintain a suppose register where all the routing informations, from source to destinations, all the possible route informations, all the informations are listed in this particular table. So that means some informations may not be required throughout the network, throughout the communication also, but as its nature is like this, that it maintains all its records, so it simply record all the informations of its of the network throughout the transmission. This is called proactive. That's why it is also known as a table driven routing protocol. And the popular proactive protocol is suppose DSDV. Okay. Similarly, the reactive means on demand protocol means when there is some demand arise that from this node to this node I have to find a route. Okay, at this point of time this category of routing protocol is in active mode. That means on demand route discovery by flooding the network with route request packet. That means when there's a requirement of a route, then only this category of protocol is in active mode. And the famous popular reactive or on-demand protocol is suppose AODB and DSR. In case of proactive, OSLR and DSDV. In reactive, it is AODB and DSR. Now, right, proactive or table-driven routing protocols. Right, proactive or table-driven routing approach proactive or table-driven routing approach is similar to the connectionless approach of forwarding packets with forwarding packet approach of forwarding packet with no regard to and no regard to when and how frequently such routes are desired. full stop. This type of protocol, after full stop, this type of protocols is mainly responsible for maintaining the consistency of the network comma, up-to-date routing information from each node, to every other node in the network. Full stop. After full stop, the routing information is kept. The routing information is kept in a number of different tables. The routing information is kept in a number of routing tables. And they respond to changes respond to changes in network topology by propagating updates they respond to changes in the network topology by propagating updates throughout the network in order to maintain in order to maintain a consistent network view. In order to maintain a consistent network view. So this is a table driven. So basically the entire routing is based on some predefined tables. In simple terms, we can say that in case of proactive or table driven routing protocols, every root informations are already present in some tables. Okay, maintained in some tables, and we have to perform accordingly. So that means if I want to send a packet from node A to F, so for this transmission, simply select the best possible route from the existing table and accordingly send the data. This is called table driven or reactive protocol. Oh, sorry, proactive protocol. And disadvantages, right? Disadvantages or limitation. That means in proactive or table driven, we are maintaining the root information for each and every one. That means it is not necessary that from every node to every node, I'm going to send the data throughout the network. That means we are storing some unnecessary information also, but we did not know that these informations are going to use or not. That's why I have to store it. So simultaneously, that much of data or that much of memory I have to allocate. Okay, जितना हम लोग डाटा रखना चाहते हैं उसी हिसाब से we have to allocate the memory. The first limitation is respective amount of data for maintenance. जितना डाटा हम लोग को respective amount of data for maintenance. जितना डाटा हम लोग उस टेबल के अंदर या जो इंफॉर्मेशन है उसके अंदर हम लोग रख रहे हैं, फॉर मेंटेनेंस ऑल्सो सेम डाटा हम लोग को चाहिए. Next point is slow reaction on reconstruction and failures. Slow reaction on reconstruction and failure. Because in this type of protocol, it looking for the entire configuration. किसी एक नोड या दो नोड के बारे में यहाँ पे इंफॉर्मेशन नहीं है. Here it store the information for the entire network. अगर कहीं पे भी नेटवर्क में कोई चेंजेस आया, कोई नोड एग्जिस्ट नहीं करता या one new node is joined in that family, so for reconstructing the entire table it will take some time, because the node may be associated with different nodes. For that, for every node they have to update the information. That means in this type of protocol, basically before the routing operation, before actually transferring the data, a huge amount of work need to be done. Okay? This is called proactive or table driven. So basically in this category of protocol, a table is maintained, a routing table is maintained, and the routing operation will occur according to the table information. Then next come to reactive or on demand. So basically in table driven, what happened? We are of the entire are in active mode, some nodes are in sleep mode or dead mode. Although they are a part of the network, but they are not a part of the any transmission. But since the nature of the protocol is to maintain the information for each and every node, so in table driven I have to mention maintain the record for the entire nodes. It will increase the time requirement for the transmission. To overcome this issue, there's another set of protocol is designed, which is known as a on demand. So basically, as it names says, when there is any demand or requirement arise, then only it will going to work. So basically in on demand, what happened? When any requirement arise for any kind of route or any kind of transmission, then only it will go for searching the best possible route, and accordingly it store the information. And basically in on demand, these protocols are only responsible for interacting with the active nodes, because active nodes are participating in the transmission. The dead nodes are not going to participate in the transmission. So that's why in on demand routing protocol, in table driven, you can write the example of table driven protocol is like, suppose DSR, no sorry, not DSR, DSDV, DSDV, OSLR, WRP, etc. Right? In on demand routing protocols were designed to reduce okay, right a little bit fast because the meeting will going to end in 5 minutes. On demand routing protocols reduce the overheads. In time driven table driven protocols, by maintaining information for active routes only. Full stop. Active routes only. Full stop. When a node requires a route, when a node requires a route to a destination, it initiates a route discovery process within the network. route discovery process within the network. Full stop. After full stop, once a route has been established, it is maintained by a route maintenance procedure route maintenance procedure until either the destination becomes inaccessible, along every path from the source,